Okay, in this video, we're going to talk about geometric sequences. And a geometric sequence is a sequence that consecutive terms have a constant factor. So with arithmetic sequences, we said that we keep adding the same value to get the next term. With a geometric sequence, we keep multiplying by the same value to get the next term. And that value that we keep multiplying to get the next term is called the common ratio. And we denote that with an R. The nth term of a geometric sequence looks like this. We have an is equal to a1, which is our first term, times the common ratio to the power of n minus 1. So in the first three examples, we are going to look at these sequences and determine if it is a geometric sequence. And if it is a geometric sequence, we are going to state what the common ratio is. And that is the value that you keep multiplying each term by to get the next term. To go from -4 to -1, I would have to multiply by 1/4. Then to go from -1 to -4, again, I would have to multiply by 1/4. And then to go from -1/4 to -1/16, I would multiply by 1/4. And then to go from -16 to -1/64, again, that would be 1/4. So we continue to multiply by the same factor to get from one term to the next. So this is a geometric sequence, and the common ratio would be 1/4. In example 2, to go from -2 to -4, I would have to multiply by 2. And then to go from -4 to -8, I would multiply by 2. And then from -8 to -16, multiply by 2. And then again, for the last two terms, I would have to multiply by 2. So again, to go from one term to the next term, we are multiplying by the same factor. So this is a geometric sequence, and my common ratio would be 2. Now in example 3, if I want to go to from -4 to -2, I would have to multiply by 1/2. Then to go from -2 to 0, I would have to multiply by 0. So right off the bat, I can see, just from looking at the first three terms, that I don't have a common ratio. I'm not multiplying by the same value every time. So I'm going to erase this so we know it's not a geometric sequence. But if you notice, it is an arithmetic sequence because, remember, arithmetic sequences, you keep adding the same value to get from one term to the next term. So from here to here, I would add 2. From here to here, I would add 2. And I would add 2. So I'm adding the same value every time. So this is arithmetic with the common difference of 2. So in example 4, it asks us to find the first 5 terms of the geometric sequence, given the first term and the common ratio. Now there are two ways that we can do this. We know what A1 is, that's 36. To find A2, A3, A4, and A5, I can just continually multiply by 1/6 to get the next term, because the common ratio is what we use to go from one term to the next. It's what we multiply to get the next term. So if I take 36 and I multiply by 1/6, that's going to give me 6. Then if I multiply by 1/6 again, that's going to give me 1. And then if I multiply by 1/6 again, that's going to give me 1/6. And then for the last term, A5, that we need to find, if I multiply by 1/6 one more time, that's going to give me 1/36. So here are our first 5 terms. Now the other way that we could have done this is found the nth term. So remember, the nth term of a geometric sequence looks like this. So we could have found the nth term and then plugged in each value of n from 1 to 5. So A1 is 36, R is 1/6, and I would raise it to the n minus 1 power. We already know what A1 is because that was given to us, but if we wanted to find A2, then I would plug in 2 for n, and that would give me 6. Then I would plug in 3 for n. That would give me 1. Then I would plug in 4, and that would give me 1/6. And then to find A5, I would plug in 5 for n, which would give me 1/36. So we could do it one of two ways. We could just keep multiplying by 1/6, or we could find the nth term and plug in our value for n. For example 5, we need to find the first 4 terms of the geometric sequence starting at A1 given the 2 terms. So we have that A8 is 64 and A11 is 512. So we need to use this information to find A1, and then we also need to use it to find our common ratio, so we can use that common ratio to find the rest of the terms. So what we're going to do is we're going to set up 2 equations with this information. Using this information here, that A11 is 512, and knowing that our general form for the nth term looks like this. I'm going to plug in 512 for the nth term, and since 512 is the 11th term, I'm going to plug in 11 for n. So then 11 minus 1, let me erase that and rewrite it as 10. Then we're going to do the same thing for A8. I'm going to come up with another equation. A8 is 64. So I'm going to plug in 64 for the nth term, and then since n is 8, I'm going to plug that in for n, and I get 8 minus 1, which is 7. So now I have these 2 equations, and I can use these 2 equations to solve for A1 and R. Because what's in between here is multiplication, in order to get rid of the A1s to solve this for R, what I have to do is divide both equations. So I'm going to take the first equation and divide it by the second equation. So I have 512 divided by 64 is equal to, and then A1 divided by A1 is just 1, and those disappear. And then I have r to the 10th divided by r to the 7th. Using our rules of exponents, when I divide, I subtract my exponents. So if I have r to the 10th divided by r to the 7th, I would take 10 minus 7 and get r to the 3rd. So now I have r to the 3rd is equal to 8, because when I take 512 and divide by 64, I get 8, which means r has got to be 2. So here's one important piece of information that we need. We found r. Now we can use that r to plug it back in and find our A1. So if I use this second equation right here, it doesn't matter, I can use the first equation. I'm just picking the second equation because the number is smaller and it will make the arithmetic easier. So I'm going to plug in r for 2 into this second equation here that I boxed in with blue. So I have 64 is equal to A1. R is 2 now that we know that. And then when I take 8, since n is 8, when an is 64, I'm going to plug in 8 for n, and I get 8 minus 1, which is 7. So that gives me 64 is equal to A1. 2 to the 7th is 128. And then I'm going to divide both sides by 128 to solve for A1, and I get that A1 is a half. So here's the other important piece of information that we know. Now that we have our A1 and our value of R, we can write down our nth term. So I have 1/2 times 2 to the power of n minus 1. There's our nth term. Now, if we start at A1, it says we need to find the first 4 terms. So A1, we know is 1/2. We have that. Then to find A2, since R is 2, that's my common ratio, I'm just going to keep multiplying by 2 to get the next term. So if I take 1/2 and multiply by my common ratio, which is 2, that gives me 1. Then to get A3, I multiply by 2 again, that gives me 2. And then to get A4, I multiply by 2 again, and that gives me 4. So here are my first 4 terms. So you can either continually multiply by your common ratio, or you can plug your value of n for each term into our nth term and get each term that way. Okay, for example 6, it says find A8 for the geometric sequence given the first 4 terms. So there's a couple different ways that you can do this again. You could figure out what your common ratio is and just continually multiply by the common ratio until you get to the 8th term. Or you can come up with the nth term, your general statement for this sequence, and then plug in n is 8. And we're going to do it both ways to practice. So to get from 3 to -6, I have to multiply by -2. And then to go from -6 to +12, I have to multiply by -2 again. To get from 12 to -24, I have to multiply by -2 again. So we can see that R is -2. Our A1 is 3. So we can set up our nth term by writing that our first term is 3, our R is -2, and we're going to raise this to the power of n minus 1. So now to find the 8th term, I'm going to plug in 8 for n. So I have 3 times -2 to the power of 8 minus 1, which is 7. Then I can put that in on my calculator and take -2 to the power of 7. That's going to give me -128. And then multiply by 3, and that's going to give me -384. So that's using the nth term. The other way we can do it is we have the first term, the second term, the third term, and the fourth term. So when I go to find A5, I have to take -24 times a -2. That's going to give me a +48. Then I just have to keep multiplying by -2 until I get to A8. So if I take 48 times a -2, that's going to give me a -96. Then when I multiply by -2 again, that's going to give me a +192. And then when I multiply by -2 again, that's going to give me the -384 for the 8th term. So here are the 2 ways that you can do it. Just keep multiplying by your common ratio, or you could just find the nth term and plug in 8. In example 7, we're going to find the 7th term for the geometric sequence given. I'm just going to find the nth term and plug in the value of n for the term that we're looking for. So if you notice, to get to each of these terms, I have to keep multiplying by -4. If I keep multiplying by negative 4, I'm going to get all of these terms. So r is negative 4. My a1 is my first term, which is negative 5. So when I set up my nth term, I'm going to have negative 5 for my a1. Then I'm going to have negative 4 to the power of n minus 1. So now to find the 7th term, I'm going to plug in n is 7. So I have negative 5 times negative 4 to the 7 minus 1, which would give me 6. So I would take negative 4 to the power of 6, and I would get 4,096, and then I would still have to multiply by negative 5. So my final answer is going to be negative 20,480. So that's my A7. For example 8, we need to find the 6th term of the geometric sequence. Now this one's got A's in it, however, you still follow the same procedure. To get from one term to the next, I just keep multiplying by 4. So my R is 4, and my A1 is A. So to find my nth term, my first term is A, my R is 4, and I raise it to the power of n minus 1. So now to find the 6th term, I just plug in 6 for n. So I have A times 4 to the power of 6 minus 1, which is 5. So I'm going to take 4 to the power of 5, and I'm going to get 1024, and then multiply that by A, and I'm going to get 1024A. So there is my 6th term.